So today we'll start with Anticonvulsants Part II. So this is a classification of the drugs which we have seen in the previous class also. So you can see here barbiturates. Mainly we have Phenobarbitone, Phenobarbitol. Then Hydantoins we have phenytoin, mephenetoin, ethotoin, etc. Then trimethadione, paramethadione, oxazolidines. Then in succinimides, we have phensuxinimide, metsuxinimide, etc. This is the urea and monoacyl urea derivatives. We have carbamazepine and phenacetamide. Then clonazepam is the benzodiazepine. This is the structure of clonazepam. Then there are miscellaneous compounds like primidone and valproic acid. This is the structure of those compounds. So you can see here SAR of anticonvulsants. So this is the general structure of the anticonvulsant drugs. So in this R position, you can see here in this R double dash position, based upon the substitution in this particular position, you get the different derivatives. So this R double dash position, when you substitute the different groups, for example, in barbiturates, when you substitute this amide group, you get this R double dash portion, you substitute this amide group, then you get the barbiturate derivatives. Similarly, Hydantoins. When you take Hydantoins, in this R double dash portion, you substitute with the NH group. So you get the Hydantoin derivatives. So when you compare with barbiturates, Hydantoins are 5-membered rings. So you can see here the total number 1, 2, 3. Amide group comes. You will get the barbiturates. Then when in this R dash position, when there is a NH group, then those class of drugs, they are called as the Hydantoins. Then in this R dash double dash position, when there is oxygen atom, you get the oxazolidines. Similarly, in this position, when there is CH2 group, this is called as the Suxinimides. Okay, so the general structure. So this is a structure which is common for all the anticonvulsant drugs. So based upon the substitution in this R double dash position, whatever group is substituted, based upon that you get the different derivatives. So these are the different classes of drugs, and apart from this there is also certain other classes also. Now we'll go to the next SAR of Hydantoins. So when you take, this is the general structure of Hydantoin. Okay, so this Hydantoin is nothing but imidazole, the basic ring, imidazole dione, imidazolidine diones is Hydantoin. Okay, so you can based upon the substitution in the R1, R2 and R3 position, you get the different Hydantoins. So you can see here in phenytoin. So we have in our syllabus we have phenytoin, mephenetoin and ethotoin. In phenytoin, you can see here in R1, that is this portion, it will be just hydrogen atom. Whereas R2 and R3, that is these two positions, the phenyl group will be present. Okay. Whereas in mephenetoin, you can see these are the substitution. R1 position there will be methyl, R2 ethyl group, and R3 position there will be the phenyl group. Then ethotoin, there is an ethyl group which is present. Okay, in the R1 position. So there is an ethyl group. And in the R3 and this R5 is nothing but this one, R2 and R3, it is mentioned as R5. That means the fifth portion. Okay, it is nothing but this one, R2 and R3. So it consists of the phenyl and the hydrogen. So you get the different Hydantoins based upon substitution in the R1, R2 and the R3 positions. Okay, so a phenyl or other aromatic substituent at C5 is essential for the activity. So this is a C5. So we start numbering from this nitrogen 1, this is second position, this is third, this is fourth, and this is the fifth position. Okay, so this R2 and R3 substitution, it is in the fifth position. Okay, so when there is aromatic ring in the fifth position, it will have good anticonvulsant action. Whereas alkyl substitution at the position 5, it causes sedation. Okay, so if in this position, if there is an alkyl group, so for example, if you take in mephenitoin, there is a alkyl group. So in that case, the particular drug, it will be causing sedative effect also. Okay, so among other hydantoins, like spirohydantoins, thiohydantoins, these are all the different derivatives. So these compounds, all these compounds, they exhibit activity against chemically induced convulsions, and some are ineffective against electroshock induced convulsions. So you can induce the convulsions, that is when you are when you are going for the discovery of an anticonvulsant drug, when we have to find out whether the drug will be having anticonvulsant activity or not. So for that purpose, in animal studies and all, you can chemically induce the convulsions, or by giving electric shock also you can induce the convulsion. So in those electrically induced convulsions as well as chemically induced convulsion, most of the drugs are found to be active. So this is the SAR of Hydantoins. Now the next class of drug, that is barbiturates. So this is the structure of barbiturate. So barbiturate is nothing but it consists of the pyrimidine ring. So this is the pyrimidine ring which is being present. Pyrimidine trion, that is nothing but barbiturate. Okay, so this is the general structure of a barbiturate. So based upon the substitution in the different position R1, R2 and R3, you get the different barbiturates. So you can see here, this is the structure of phenobarbitone. So in phenobarbitone, R1 portion, it will be hydrogen atom, whereas R2, it will consist of the ethyl group, and in R3 portion, it consists of the phenyl group which is being present. Okay, then mephobarbiton. Mephobarbiton, here in this R1 position, it consists of a methyl group. R2 and R3 portion, it consists of the one ethyl and one phenyl group. So we'll come to the structures in the later slides. Okay, so optimum activity, that is anticonvulsant activity, it is observed when one of the substituent at C5 is phenyl. That is in this fifth portion, if one of the substituent, if it is an aromatic ring, in that case, that particular drug will be exhibiting optimum anticonvulsant property. So if you take in phenobarbitone, mephobarbiton and all, they consist of the phenyl group. So they possess anticonvulsant property. Whereas if both the diphenyl derivative, that is in this fifth portion, if R2 and R3, if it is two aromatic ring, then that particular compound has less activity than phenobarbitone. Then N2 and N3 substituents also results in increased activity. N2 and N3 is nothing but that is here in this third position when there is substitution. Then second position, thio group, thiobarbiturates. In all that case, the activity will be increased. Then 5,5-dibenzyl barbituric acid. So it will be causing convulsion. So that is a compound which can lead to unwanted side effect. That is, it can cause convulsion rather than treating convulsions. Now we come to the next next class of drug, that is benzodiazepines. So you can see here, so already we have learned about benzodiazepines in the sedative and hypnotic topic. So here it is the benzodiazepine ring is shown here. Okay, so you can just see here, it consists of an aromatic ring which is being fused with the diazepine ring. So
earphones on.
So you can see here diazepam. Okay, so diazepam, then clonazepam. Clonazepam is a drug. What is there in a anticonvulsant topic? So in clonazepam, you see in this R3 position, there is a nitro group, and this R2 position, it consists of the chlorine atom. Carbon position. Please mute your. Yeah, I can understand who is talking there. Please mute your videos. Sorry, audio. Okay, so based upon the substitution in the R1, R2 and R3 positions, you get the different benzodiazepine derivatives. So the presence of an electron withdrawing group, okay, or atom at the position 7, it will increases the anti-epileptic activity. That is, in this R3 position, the presence of this nitro group and all, it will increases the anti-epileptic activity. While electron donating substituents, that is at the 7, 8 and 9 position, it will decreases the potency. Okay, so a phenyl group at the 5th position, this is the phenyl group which is present at the 5th position. It is essential for the anticonvulsant property. In this phenyl ring, when there is a substitution in this R2 position, that is ortho, this is ortho position, right? This R2 and this is ortho position. So when there is some ortho substitution like halogen atoms, etc., in that case the activity will be increased. Okay, so the electron withdrawing group at ortho or diortho position at the 5-phenyl, it will increase the activity. That is, in this aromatic ring, when there is substitution in this R2 position or in this position. So these are the two ortho positions. So if the both position there is some substituent, it will increases the activity. Whereas when there is in the para position, the substitution, it will decrease the activity. Okay. And methyl substitution at the first position, it will also have high potency. For example, in diazepam, there is a methyl substituent. Now the SAR of succinimides. So when you take succinimide, so this is the structure of succinimide. Okay, so so you can see here the succinimide derivative. So it is nothing but it is a saturated pyrrole ring, pyrrolidine ring, which is being present. Okay, then or pyrrolidine dione. Okay, so based upon the substitution in the various positions, you will be getting, that is R1, R2 and the R3 position, you will be getting the different succinimides. So here we have phensuccinimide, metsuccinimide and ethosuccinimide. So based upon the substitution in this R3, R2 and R1 position, you get the different succinimides. Okay, so you start numbering from this nitrogen atom. Okay, so metsuccinimide or succinimide and phensuccinimide, they have phenyl substitution which will make them active against electrically induced convulsion. So I told before itself, convulsions can be induced by either by using drugs, chemicals, or by electrically induced convulsions. Okay, electroshock method and all. Okay, so the phenyl substitution, it will increases the potency. Then N-methylation, it will decrease the activity against electroshock seizures and impart more activity against chemically induced convulsion. So this substitution, it will affect the activity. It will be producing more action against chemically induced convulsions rather than electroshock seizures. Okay, then this is the structure of valproic acid derivative, okay, or sodium valproate, which is also called by the name Valium. Okay, so there are derivatives of valproic acid. Okay, so based upon the substitution, you get the different derivatives. So valproic acid is an active compound. It is an anticonvulsant drug, powerful anticonvulsant, and depending upon the variation in the side chain, you get the different derivatives. Okay, and when there is some unsaturation or introduction of double bond in this compound, it will decreases the anticonvulsant property. Okay. Now we come to the drugs which are used as anti. So we have seen the SAR of the drugs. Now we'll come to the different classes of drugs. So first we'll come to the barbiturate derivatives. So phenobarbitone. So here we can see the structure of phenobarbitone. Okay, so phenobarbitone or phenobarbitol. So this is a drug which is used in the treatment of all type of seizures except absent seizures. Absent seizures, it is also called as the petit mal type of seizure. Okay, so in different types, there are some 7 to 9 different types of seizures are there. So yesterday I've shown you in the last class the different types of seizures and all those things. Okay, so you can just go through the what are the symptoms which is related to each type of seizure and the variation in the type of the seizure. Okay, so this phenobarbitone, it is used in all type of seizure except absent seizures, and it is also the first line of drug for the treatment of neonatal seizures. Neonatal seizure is nothing but the seizure which occurs in newborn babies or the babies who are less than 4 weeks old. Okay, so in some kids after the birth, they'll be showing some symptoms of epilepsy. So that may be due to the damage in the brain, or if the brain is not properly developed, in such kids they'll be showing some epileptic seizures. So based upon that, they can understand whether the brain has developed properly or not. So because of that, in smaller kids it will be shown, but once the child grows on, the brain also starts growing, and thereby it will be controlled in many kids. Apart from this, it is also used to treat status epilepsy. Then it is also used to treat trouble in sleeping, that is in the treatment of insomnia, anxiety, and drug withdrawal. Then it is also used for alcohol detoxification and benzodiazepine detoxification. That is because of its sedative property. Then the same point is repeated. It is used for insomnia, but it is not recommended because of the risk of addiction and other side effects. So it causes addiction. Because of that only, the barbiturates are replaced by the benzodiazepines. And overdose, it may lead to pulmonary edema. Okay, that is fluid accumulation will be there in the lungs, and it will lead to pneumonia and other problems. Then renal failure, bradycardia, that is hypothermia, then hypotension. So these are all some of the side effects which is related to phenobarbitol. Now methobarbitol, this is also barbiturate derivative. It is an anticonvulsant which is used in the treatment of epilepsy. So here you can see in the structure, here in the fifth portion there is 2 ethyl groups, and in the first portion there is a methyl group. That is a difference here. Okay, so if you take this particular drug, it has similar properties to phenobarbitol. So whatever uses we have discussed about phenobarbitol, you can write those same uses. Now, next is the Hydantoin derivative, that is phenytoin. Phenytoin, this is the structure of phenytoin. So when you take the structure, it starts numbering from this nitrogen 1, 2, 3, 4, and this is the fifth portion. So the fifth portion, there is 2 aromatic rings. So it is 5,5-diphenyl hydantoin. Okay, so phenytoin is an anti-seizure drug which is used in the treatment of tonic-clonic seizure, focal seizures, and status epilepsy. But this is also not used in absent seizures. And this particular drug, the intravenous form, is only used in status epilepsy. And this particular drug, it will suppress the abnormal brain activity which is seen in seizures by reducing the electrical conductance among the brain cells by stabilizing the inactive state of voltage gated sodium channel. So you can already we have discussed that epilepsy, it occurs mainly because of the rapid firing of the neurons. Okay, so there will be abnormal neuronal activity, or the cerebral neurons will be in the high excited state. So it will suppress the excessive neuronal activity, and thereby it will control the seizure. And apart from this particular drug, it is also used in heart arrhythmias. Arrhythmia is nothing but the improper rhythm of the heart. Okay, so there will be variation in the rhythm. So that is mainly in ventricular tachycardia, atrial tachycardia, and all. It can be used. Okay. Then this particular compound, it also has some side effects like sleepiness. Then it also leads to liver problems, bone marrow suppression, low blood pressure, etc. Apart from this, it is also used in trigeminal neuralgia, which is nothing but it is a chronic pain disorder. It leads to severe pain. That is mainly because of the defect in the trigeminal nerve, which leads to trigeminal neuralgia. So this is a synthesis of phenytoin. So when benzyl, so we have done practical also for this phenytoin. So benzyl, which is the diketo compound, when it is being treated with urea, the condensation of benzyl with urea, it results in the formation of this intermediate compound. Then what will happen is, so this is the pinacol-pinacol rearrangement reaction. Then this one of the phenyl group, this phenyl group, it will migrate to this carbon. So from this carbon, it will migrate to this carbon. So both the phenyl groups will be attached in the same carbon. And here it will become the keto group. Okay. So that particular compound is nothing but it is called as phenytoin. So here loss of so here what happens is, one molecule of water will be lost, and thereby you get phenytoin. So benzyl, the condensation of benzyl, which is a diketone with urea, it results in the formation of this intermediate compound. So from this intermediate compound, what will happen? This is the pinacol-pinacolone rearrangement reaction. So this aromatic ring, it will migrate. Okay, so it will migrate to the next carbon. So here it will be 1,2 shift which will be taking place. So shifting of this aromatic ring to this adjacent carbon atom, and loss of one molecule of water, and thereby it will form the keto group, and thereby it will form phenytoin, which is the anticonvulsant. This is the structure of mephenytoin. Mephenytoin is also, it is a hydantoin. The only difference is here there is a methyl group, and instead of phenyl group, here it is a ethyl group. Okay, so it is used as an anticonvulsant, and the metabolite of mephenytoin, which is nothing but 5-ethyl 5-phenyl hydantoin. Okay, that is this methyl group will be removed. So you get 5-ethyl 5-phenyl hydantoin. So that was the first compound which is used as a hypnotic agent or in the treatment of insomnia. Next is clonazepam. This is a benzodiazepine. Okay, it has anticonvulsant property, muscle relaxant property, and it is a potent anxiolytic, which can be used in the treatment of anxiety disorders, panic disorders, etc. Then it is also used in the treatment of different psychotic problems like mania. Maniac is nothing but is a extreme psychotic disorder. Okay, and acute psychosis. Okay, together with other first line drugs like lithium, haloperidol or risperidone. So lithium is one of the compound, that is in some people psychotic in one type of psychotic illness, when the levels of lithium in their body is less, or in the blood the level of lithium when it is less, it leads to psychosis. So in such people lithium replacement therapy will be done. Okay, so this particular drug, it is used in the treatment of mania, other maniac or other psychotic disorders, along with other antipsychotics drug like lithium haloperidol, risperidone, etc. And this is a long-acting benzodiazepine, which is a longer duration of action, and it is a chlorinated derivative of nitrazepam, and therefore it is a benzodiazepine, and it acts by enhancing the actions of gamma aminobutyric acid. Okay, so it will potentiate the action of GABA. So this is the uses of clonazepam. So here there is the nitro group which is there in this particular position. Now this is the structure of next compound, urea and monoacyl ureas. Example, we have carbamazepine. This is the structure of carbamazepine. Okay, so it is a anticonvulsant and also it is a mood stabilizing drug. Okay, so it is used in the treatment of epilepsy. That is mainly it is used in partial seizures, generalized tonic-clonic seizures, and in mixed seizures it can be used. That is different types of epilepsy this drug can be used. And apart from this, it is also used in bipolar disorder as well as trigeminal neuralgia. Okay, for the treatment of that also it is used. Then it is also used in various other conditions like attention deficit hyperactivity disorder. Okay, so in some kids you can see they'll be very hyperactive, so that is also related to the brain development. Okay, autism and certain kinds of learning disabilities will be exhibited, and hyperactive activity will be observed. In such case also this particular drugs can be used to reduce the hyperactiveness. Then in schizophrenia, which is also a type of psychotic illness, and post-traumatic stress disorders, after trauma the stress related to that, it can be used. The next compound is urea and monoacyl ureas. This is the structure of phenacetamide. So it is nothing but phenyl acetyl urea. So this is the NH2 C double bond O, NH2 is urea, then CH3 C double bond is acetyl group, and this is the phenyl. So it is phenyl acetyl urea. So three parts are there. So this is the phenyl ring, this much is the acetyl group, and this is the urea. Okay, so it is an anticonvulsant of the acetylurea class. It is a congener. Congener is nothing but it is a chemical derivative, whether it will relate to the structure or activity to that of phenetol. Okay, and it is related structurally, or it is a open chain analog of phenytoin, and it is structurally related to barbiturates and other Hydantoins. So the open chain structure, it is mainly used for the treatment of epilepsy, but its use is restricted because of the toxicity which is related to that. Okay, so now this is the last slide. So you can just if you have any doubts on any particular slide, you can just raise your hand so that your queries will be answered. So whether you're hello,
yes ma'am,
any doubts is there in any particular slide, you can talk now. So this is the last slide. If you have any doubts on any particular slide, you can please ask. Should I go from the slide 1? Shall I
yes,
go
ma'am.
from the slide 1 so that you can? So this is classification. You just can see that. So this, any confusion is there in this slide?
No ma'am.
Okay, so here you just have to write because the question can be asked in compare the SAR of different anticonvulsant drugs. So in that case, you have to write this general structure and just show this the different class barbiturates, hydantoins. You can even write here one examples. For example, barbiturates, you can write one example here. Then in hydantoins you can write an example. So like that, each class one example also you can just show. So what is the structural comparison of anticonvulsant? That is a very important question. So in that case you can compare and write. So no any confusion is there in this slide?
No, ma'am.
So we'll go to the next slide. Do you have any doubts on that? Please, you can raise your hand. Hello.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
You can, if you have any doubts in this slide, you can just raise your hand. You can ask the questions. I hope no confusion is there in this slide.
No, ma'am.
Which slide next? This slide?
No, ma'am.
No, ma'am.
Hello.
Yes, ma'am.
Yes, ma'am.
We are running out of time. Just we have only 1 minute. If you have any doubts, you can just ask.
Ma'am, are we supposed to write example for each?
Can you repeat the question? Hello.
Ma'am, are we supposed to
Not clear.
write
It's not clear what you're asking.
one example for each?